Shri Gurubhyo Namaha. Welcome to Ekalaiva online teaching class, children. Today we are going to see in geography, and the lesson name is the changing earth. In geography, the third lesson, changing earth. For thousands of years, people believed that the continents were fixed in their position. The distribution of land and water, however, has not always been the same. Today we are saying the distribution of land and water has not always been the same on the earth's surface. We are going to see about that only in this changing earth. See, what is this? Last lesson we study about this. What is this? The inside the earth we studied about this. This is crust, mantle, and this one is core. This is outer core and this is the inner core. This is the topmost layer of the earth. This is crust. This one is called crust and this is mantle and this one is outer core and this is the inner core, the center of the earth, this one. Then let's see first about continental drift. Continental drift. The gradual movement of the continent across the earth's surface. Continent drift means gradual movement of the continents. Slowly it will move across the earth's surface. Earth's surface means here. This is only the earth's surface, no? From here, it will gradual movement of the continent. Okay. About this, Wegener, Alfred Wegner, a German meteorologist, Alfred Wegner, made an attempt to explain the present day distribution of the continent and oceans, and he proposed that all land masses are joined together into a supercontinent called Pangaea. See, now we know North America, South America, Asia, Europe, and the continents are separated. But millions of years ago, all are joined together into supercontinent, all in one landmass. All the continents in one landmass. That is called Pangaea. What is meteorologist? A person who study and forecast weather. In TV we watch, they will tell today it will be rain. Today in that area it will be rain. They will tell, that person only called meteorologist. Then let's see about Pangaea. What is Pangaea? Pangaea is a supercontinent that included all current land masses. Now, continents are there, the current land masses believed to have been existent before the continents broke apart. Before the continents broke, it all in one land masses. All the continents in one land masses. That is called Pangaea. Okay. See, continental drift was a theory that explained how continents shift positions on Earth's surface, how it was shifted. The continental drift theory shows that how the continent, the position of the continent, moved, how it's broken, how it's moved. In 1912, by Alfred Wegner, a German meteorologist, he only say about this continental drift. He only gave this continental drift theory. Wegener suggested that the rotation of the earth caused the continents to shift towards and apart from each other. Today, we know that the continents rest on massive slabs of rock. See, the continents are rest on the massive slabs of rock called tectonic plates. You can tell lithospheric plate also. Tectonic plates or lithospheric plates. the plates are always moving. See, now also it's moving. Okay, and interacting in a process called plate tectonic. Plate tectonic. See, Alfred Wegner said the world used to be one large landmass millions of years ago. One large land millions of years ago. That land was called Pangaea. Pangaea kept moving apart here few centimeters each year. Few centimeters each year the continents are moving. Okay. After millions of years it became the world we see today. He is only Alfred Wegner. Alfred Wegner is only the meteorologist. See, see this 237 million years ago, how the land was. See all the continents, all the landmass in one supercontinents. All this are calling all the continents in one landmass. All the continents in one landmass. See the year 237 million years ago. Before 237 million years before, like this. See, after 195 million years ago, this one. See, rightly. This Asia, this is Eurasia, no, this one is Asia, our continent. See this North America, see this South America, Africa, and all these are, see, even India also near this, nearby Australia, Antarctica, and Africa, see, it's here. And then in 152 million years ago, what happened? North America separated, see here. Africa and South America is in one landmass. Even India is here. Antarctica and Australia also in one landmass. Asia is here. Asia, see, Asia is here. In 66 million years ago. 66 million ago, see, separated. North America is here. South America is here. See, Eurasia. Eurasia means Asia. Africa, South America and Africa separated. But India is far away from this Asian continent. It's not joined in this Asian continent. See, Australia and Antarctica is one landmass. Okay, slowly it was separated. See, and now we'll see in the map and all. No, see, North America is here, South America is here. See here, Africa, Asia. This is Asia. See, India joined in this. India is joined. Okay. See, Australia. Australia. Australia is here. Okay. See, in this, Australia is near India. Okay. See, South America and Africa joined together. See the landmark. It's joined. Let's see about tectonic plates. Tectonic. A tectonic plate also called lithospheric plate. Lithospheric plate is a massive, irregularly shaped slab of solid rock. On that only the continent all. Okay, generally composed of both continental and also this oceanic lithospheric. Tectonic plate is a massive, irregularly shaped. You know, it will not be in square shape or rectangle shape like this, or it will be in like this rectangle, square, or circle. It will be some wall like this. Like, see, even India, if we see, means it will be like this, no? It's a irregularly shaped slab of solid rock, generally composed of both continental and oceanic lithosphere. See, this tectonic plates, it's all moved now, the present. Lithospheric plates broken into a number of plates known as the lithosphere. The lithosphere broken into a number of plates. The topmost layer of the earth, I told you know the crust. It's broken into a number of plates known as the lithospheric plates, and also we can call as tectonic plates. You will be surprised to know that these plates move around very slowly. Slowly it's moving. Now also it's moving. Just a few millimeters each year. Each year, few millimeter it's moving. This is because of the movement of the molten magma inside the earth. See the mantle. Mantle is full of magma only, no? The hot liquid fluid, that one. Molten magma inside the earth. The molten magma inside the earth moves in a circular manner. It's in circular manner like this. Let's see what happened. Tectonic forces. Because of the tectonic plates, what's all happening? Because of that plates, what's all happening? That in this two forces, in this two tectonic force, two endogenic force and exogenic force. Endogenic means inside, exo means outside. Outside means on the surface. On the surface. Endogenic force, that for the forces that act inside the earth. Exogenic on the surface of the earth. The cause on the surface of the earth, this endogenic inside the earth. Okay. See, evolution of landforms. What all will happen if the earth movements? If the earth moves, what all? See, in endogenic force and this is exogenic. This is endogenic and this exogenic. Endogenic, sudden forces. See, in the sudden force, earthquake, volcano, landslides. The landslides, you don't know, landslides and diastrophic forces. And then building mountains, it will be shake, no, that is. Exogenic, erosional. Erosional means somewhat like landslide only. All that sand, soil and all will go off and deposit in another side, another place. Okay, depositional, erosional and depositional. River, wind, sea waves, glaciers. These are the forces. These are the by endogenic and exogenic. It causes this endogenic causes earthquake, volcano and all, landslides. Okay. The movement of these plates causes changes on the surface of the earth. The earth movements are divided on the basis of the force which cause them. The forces which act in the interior of the earth are called as endogenic, and the forces that work on the surface of the earth are called exogenic forces. The endogenic force produce slow and sudden movement. It will be very slow, but suddenly it will, that causes sudden changes, that is earthquakes and volcanoes. It all will happen suddenly, no? This earthquake and volcanoes and all cause sudden movements only. Earthquake sometimes it will be there, it will be shake, no? That is earthquake. Okay, let's see about first volcano. See, this is volcano mountain, a vent or opening in the earth's crust through which molten materials erupt suddenly. Suddenly that molten, the lava will erupt. See, this is only this one, no, this is only vent. This is vent, the opening. Okay, this is vent. See, the lava is erupting and going. See, this is lava. This is the surface, this is crust and this is mantle. I showed you, no? I showed you for the first picture, crust. This is the topmost layer of the earth, crust, and this one is mantle. From here only, in the mantle only, the hot liquid fluid, the magma is coming out. See, the form of volcano. This one, this gases and ash. This is gas and ash. See, this is vent. Okay. The endogenic forces sometimes produce sudden movements and the other times produce slow movements. Sudden movements like earthquakes and volcanoes cause mass destruction. It will happen, no? Butch earthquake. Okay, over the surface of the earth. A volcano is a vent in the volcano means the opening of that volcano. That is vent. It's called vent in the earth's crust through which molten materials erupt. It will come out through the vent. The molten material, the all liquid fluid will come out, erupt suddenly. When the lithospheric plates move the surface of the earth vibrates. Lithospheric plates, that means the tectonic plates, the topmost layer, no, the crust, it will break when it's moved. The tectonic plates move. The surface of the earth vibrates. See, if it is movements, the earth also vibrates. At that time only earthquake will cause. The vibration can travel all around the earth. These vibrations are called earthquakes. An earthquake is measured with a machine called seismograph. Seismograph. The magnitude of the earthquake is measured on the Richter scale. See, if you go to doctor, he will, what you will see first, the temperature of our fever. Okay, temperature you will tell that one. The measurement is temperature, and what is using for seeing the measurement, that is thermometer. Okay, you have scale, and you will, in that how we will measure centimeter or meter, no, like that. Okay. In next class, let's see types of volcanoes and types of earthquakes. Okay. Thank you.